Welcome to the third part of Competency 10 quiz. In this video, we will continue with the limits, derivatives, and antiderivatives. Number 10, if f of x equals the rational function x minus 2 over 3x squared plus 2x plus 1, which one of the following is the simplified expression for the first derivative? Okay, one of our basic properties is that, okay, first just let me write it down, okay? What we really need to look for is this. We need to look for f prime of g minus f as it is, and then g prime. And then that will be all over g squared in the denominator, okay? So we go over and we look at our A, B, C, D options. We see that A most likely will not work, also C, okay? But what we really need to do is double check that numerator, okay? How would that actually look? Now, you can just go through the motions and calculate that. I'll write it down for you the best that I can. Okay. All right. So what do we really have? We are looking for, I'll say y prime. And in this case, let's say that f of x equals y. Okay. All right. That solves that problem. All right. So this is what we're going to get. The first thing that we need is 3x squared plus 2x plus the 1, and that will all be to the second power. Okay. All right. Generally, that might be the case that you keep that denominator all the way through to your final solution. But as we've learned, every now and again, we have items that we can simplify out. So we just need to guarantee with that numerator as we calculate it that isn't going to happen. Okay. All right. So what do we really have? Okay. I'm going to get rid of this right here. Actually, I'll rewrite it. Give us some space here. I'll put it up here. So we were looking for f prime of g minus f on its f as is, and then g prime, and that will be all over the g squared. All right, that's a better place for it. All right, so now let's get busy. So if we take the first derivative of our numerator, well, that ends up being 1. Okay, and then we just write out g as it is, which is the 3x squared plus the 2x plus 1. Okay, now we need to subtract. F on its own, we just write it down. X minus 2. Now, let's take g prime. Well, that will be 6x plus 2. Now, if you haven't watched the other videos relating to this, or you're not super comfortable with what I'm doing, I am using basic rules of differentiation along with the chain rule. So if you're a little shaky with the chain rule, remember you can always go to the end of any of my videos, and there is a good YouTube channel suggestion there. Highly recommend it, okay? So if you need it, if not, then we're good to go. Just my videos, as you know, generally I use the TI-84 and focus on it, not in-depth details, and I just mention things and mention properties. As you've noticed, we're not using the TI-84 right now. This type of basic question doesn't call for it, okay? All right, so I'll just keep going. Honestly, I'll only use a calculator if we just want to verify some values in this situation, because you need to save your brain power when you are testing. So don't do everything in your head. I don't care if you are the maximum scoring student use a calculator on the small stuff during a test. As I've stated before, your livelihood depends on this. Don't do it. Okay, now let's just put all this together here and see what we can simplify out, okay? Okay, so this gives us, oops, I need to reposition my cursor here. All right, we'll just go down. Okay, there we go. All right, 3x plus our 3x squared, that is, and the 2x squared plus the 1. Now, what are we going to subtract out? Well, I don't want to skip too many steps, okay, guys? So I'm going to go ahead and put this, let's go ahead and do these factors, put them together. I won't skip too many steps. So what do we have? 6x squared. Now, I am going to say that we have minus 12x plus 2x, which gives us minus 10x. No. Yes, does that? We have minus 2, yes, I would say minus, yeah, that is what we get. Minus 10x, and then that's negative 12 plus 2, that's minus 10, and this gives us minus 4. Okay, all right, then, okay, let me make sure I have this right. I'm like double checking myself here. Okay, yes, we should definitely be okay. All right, so let's just keep on going here and let's simplify. Okay, we just take that denominator, copy it down again, plus the 1 squared. Now let's deal with everything in the numerator. Okay, so we have 3x squared plus 2x plus the 1 minus 6x squared plus 10x and then plus the 4. So this gives us a numerator. You may already see it. It gives us a numerator of minus 3x. Okay, and where did I get that from? Here, let me circle what where I got it. So I took and combined my like terms. That's what we're doing right now. So that gives me the negative 3x squared. Now I need to go to my x's. Well, they're both positive here. Let me show you those. These like terms. Okay, so now that gives me plus 12x. And then finally here, that gives me plus 1 and plus 4. So that's plus the 5. And of course, if you look at this and you look at the denominator, well, we're not going to cancel that out, okay? So 3x squared plus 2x plus the 1 all to the second power. And that gives us, no, I'm correct. I thought I needed a negative somewhere. And that is a 3. Okay. All right. So that will give us this negative. So that's D, option D. Both of them are negative 3x squared. But the difference is, that's where my mistake is. Something didn't look. No, that's correct. Okay, hang on. I'm looking at the wrong things. Okay, the numerator checks out and the denominator, and I did write it correctly. Okay, sorry about my moment, but everything is good to go. I did actually do it correctly, okay? You know, sometimes you double check, but you got to be careful what you double check. Okay, so number 11 here. Again, we will not use a calculator. This is just a matter of knowing our rules for derivatives, and in this case, it's trig, okay? All right, so what are we going to do here? Well, I see some things that are clues and just absolute giveaways of what we wouldn't do. Okay? All right. So we need to see that this first one, this is F. Oh, here, I need to arrow down so I can, okay, now my pen works. Okay. And we turn it on. This is my F and this is my G. Okay? And the rule that we're following is F prime times G plus F as is and the G prime. Okay? So now that we look at that, and if you remember things I've said before, when we take the derivative of F, the 4 is just going to hang on and we just apply it in the end. What we need to look at for F is the derivative for secant x, and that just so happens to be secant x times tangent x. So this is what we should have to begin with. We should have 4 secant x tangent of x. Now that's just f of g. I'm sorry, f prime. Okay, now we need g. And g is simply that 3 to the x power. So now we need to add f as is, again, that is 4 secant x. But what is g prime? Okay, well, g prime is g on its own and then ln of 3, ln of the base. Okay, natural logarithm of the base, and the base is 3. Okay, so that gives us 3 to the x power ln 3. Okay, now we need to do or pick out the elements that we can factor out. Which terms are safe to pull out? Okay, I see that we have 4 secant x on both sides of our plus. Okay, we're here. Let me highlight the plus. We need to find the same things on both sides, okay? Well, tangent isn't on both sides. However, our 3 to the x power is on both sides. So we need this to be pulled out. Okay? All right. So let's do that. Well, they write it differently if you look at what they have. I'm going to pull it out as I see it. I see 4 secant x times 3 to the x power. And that is, now I'll put it in parentheses. And then what do I have left? I have tangent x plus ln natural logarithm of 3. Okay? So, who do we have that even looks similar? Well, A looks great because, we have the the I'm not sure where that came from. Let's get rid of it. We have that commutative property of addition. It doesn't matter, which way we add them. You can flip them, so that doesn't matter. Same thing for multiplication, so we can apply those properties. And this would mean that A does satisfy what we're looking for. Now, why would B, C, and D not satisfy? Well, let's take a look. Obviously, these are incorrect. That would be incorrect. Well, what I think is going on there is you're pulling out the wrong things. You're trying to factor out incorrect items. That's probably what happened there. Okay, and let's look at C. All right. I agree with the 3 to the x power. Okay, this right here, they just pulled out the entire first part. Yeah. Yeah, that's what they did. They pulled out the entire first part and then just left the 4. So this is incorrect factoring. That's what that is, okay? And looking at, oh, okay. This is more than incorrect factoring on D. I see the probably incorrect. Yeah, I'm not sure what happened. They're kind of putting that tangent in 2 places. Maybe that's still incorrect factoring. I'm not sure. Regardless, A is the only option that actually satisfies. Okay. All right. Now let's look at number 12. Okay. For number 12, it says E, if Y equals E with the E to the power of 2 minus 3x, what is the simplified expression? And be careful. They are asking for double prime. That's a second derivative. So we have to take the derivative twice. And we also, another thing to be wary of is that the rules of E with an exponential, okay? When you take the derivative, uh, E is as is. It's its own derivative. What we're truly taking the derivative of is that, think of it as the outside and the inside stays on its own. E would be the inside. Okay, so let's look at the exponent. Let's consider that the outside. You work from the outside in, per se. Okay, so what does that mean? It means that we need to look at the exponent and take the derivative of that and write it first. Okay, so what are we doing here? Y prime equals the derivative of the first derivative of the exponent is simply -3. Now we take that derivative of E on its own, it stays the same. Okay, it's the rules of E with an exponent. Okay, so that exponential does not change. Okay, that's the first derivative, but it's asking for the second derivative. So they put in C to throw us off. Now, Y double prime? Okay. Well, when we're taking that derivative, we leave that the -3 that you're multiplying it to, you leave that on its own. It stays there hanging out. We're not dealing with that. Okay. If you remember the rules of derivatives, how this works. So really what we're going to do is we take -3 and then we have to apply the rule again. Go back to the exponent, and then we pull down another -3, okay? And then multiply all of that to the given exponential, e to the 2 minus 3x. Multiply the coefficients together, so -3 times -3 is 9, and that becomes 9e to the exponent of 2 minus 3x, okay? And that obviously is option A. Not sure how B got that too. I tried to figure that out. The only thing I can think of is that maybe they did the exponent wrong and only took a first derivative incorrectly. Doesn't work. And then I was looking at D, and that's what I think it might have happened there. If you take the first derivative incorrectly, or one of them, let's say you take the first derivative correctly and the second derivative incorrectly, or you could flip them. The first one incorrectly, the second one correctly, or whatever. That's the only way I can think of. But then, yeah, that would be the only way. Either way, it's incorrect, and A is our only option. Okay, let's move to number 13. Okay, number 13. Suppose that h of x is a continuous function with a domain of all reals, meaning all real numbers, and that the point 6, -1 is the only critical point. Okay, this is big clue, along with this domain. Okay, which one of the following sets of conditions implies that the point 6, -1 represents a local minimum? Okay, here's the thing. The minute they gave you all this information, this should completely scream to you that we are graphing a quadratic that opens upward, and that point tells me we have a shift. Okay, that these tell us our shift. And what do they tell us? Well, let's write our equation. Okay, we can do that right now. So we have y equals, okay, and I'm shifting. So my x, because it's 6, I kind of go backwards. So it solves, if we put x minus 6 equals 0, I know that that will equal x equals 6. So I put minus 6 and I square that. Now that shift, we have to leave the -1, okay? Because if we say x is 0, then we will have -1, okay? So now, if we put all that together, we don't really have to be honest with you. We could, but you know what? Let's not. Instead, we can get y prime. But what if we put it in our calculator, graph it, and then check that out, okay? Let me show you what to do. We don't even have to get the y prime, whatever. You could do all this by hand, and I did in my notes. Well, let me show you how to get through this quickly. All right, so let's push x equals. I'm going to clear that first one out. Notice I have something on down here. I don't want that on. I'm just going to clear it out. Okay, everything else is off. So I can go up to y1. Okay, you can clear your calculator out whenever you want. You can turn things on, off, like I've shown in other videos, okay? So let's do this. I have my parentheses, then I have x minus 6, close the parentheses. I square that, and I subtract 1. Now let's graph it. Okay, yes. And that turns out correctly, okay? Luckily, they gave us all of the information that we needed to know what our h of x really is. Okay, that was highly helpful. Now, we want to know at these values in our ABCD options, what do they look like and what do they give us, okay? That's simple. And it's telling us that we need to ask our calculator about the first derivative. We know how to do that. Okay. So we push second trace. Okay. We go to 6. All right. Now I want to know about -2. So I put in -2 and it shows where I entered it and I push enter. And that says -16. So come back over here for A. That is correct. When I put that value in, the value I get when I say h prime at -2 is definitely less than 0. So that's a check for that part. Now I can go down to C and say, no, that's not true. And if C isn't true, then the whole thing is invalid. Okay. Now I need to check 0. If I put in 0, my value must be greater than 0 itself. So let's go do that. Second trace, number 6. Okay. And I just pop in 0, and push enter. See what I did? Okay. And that says negative 12. So this is not true. Okay. And I'm going to put an X on that as that not being true. Therefore, this option is not true. So negative 2 and 0 are not values that'll make my statements true. Okay. Now let's go to 5 and 7. All right. So just repeat the process. So I say second trace number 6, and I'll go with 5. 5, enter. That is negative 2. Oh, B does not work. It's saying that value should be greater than 0. This is absolutely not true. So that makes the entire thing invalid. Let's double check D, okay? So the first part checks. Well, let's try 7. Second trace number 6, type in 7, enter. And it is greater. So if X with H prime, the value of 7 is my X value, the entire value is greater than 0, so that's check mark. So the only option we can use is D. I don't know about you, but I do know how to do all of this by hand. But using my calculator and going through it in this matter with it in front of my face, proving what's wrong and what's right, I don't know, for a test, it just seems better. You can also use your do all this by hand, use your knowledge to do that. Now for y prime, what I got was this. Y prime of x equals, well, going inside out gave me 2x minus the 6, and then that would be 2x minus 12. And then you can replace negative 2 and 0 and 5 and 7 and go through the process and discover that for yourself. But my opinion is I like this better, okay? But you have to know how to derive the equation from the information. We can do that. All right, let's go to number 14. Now, for number 14, I can already tell you we will not use the calculator. This is, what do you really know about this topic? Do you understand the properties? Okay. Number 14. In the interval 4 to 9, the function f of x is concave down. Okay. Something like this. Who knows? If 4 is less than c, c is going to be over here, and 9's, I don't know where 9 is. 9, maybe 9 is like somewhere over here. Who knows? And c is less than 9. Which one of the following must be true? Okay. This is not necessarily about where 4 and 9 are. Okay. I can tell you right now, this is about what shows us what. What? The first derivative is related to average rate of change. Okay. That is slope. Okay. The second derivative tells us concavity. And if the function is concave down, this original function, then the second derivative will be a negative value. So now that I've said all that, it eliminates a bunch. There is no equation manipulation. There is no calculation. It is simply this. It is that we are going to get rid of A and C because that involves the properties of slope. We're not worried about that right now. And D says the original function is concave up, and I say no. B is correct because the second derivative at that point will be a negative value, showing that within this interval, that value of C in particular will be that negative value, okay? So option B is correct. Okay, now let's move on to number 15, and we are going to use our calculator for this, okay? For which value of C is the open interval 3 to 5, in the open interval 3 to 5, does the first derivative C equal the average rate of change for g of x equals 4x to the third minus 2x plus 4 over the closed interval 3 to 5. Okay, here's the thing. It says average rate of change. So that tells me that we're going to get the slope, okay, using the equation. And from that slope, we will take the second derivative and compare the values, okay? So let's just take that second derivative so we have it, okay? So we have g prime of x equals 12x squared minus 2. So we have him. Let's put him in the calculator, all right? All right, so we're going to do y equals, I'm clearing out everything. Get rid of the excess. Remember, we used these in another prior video. We don't want them anymore. Here we go. So let's see. It's saying, yeah, we need to go ahead and just put him in. But we don't need the original in. If we need the original in, we can do that. Let's do the 12. 12x squared, okay, the x and then the squared, if you don't remember how to do that, minus 2. Let's graph him. Okay, that looks good, all right? So now we need to find the slope at that point, all right? So we need to know what that slope is. All right, so how do we do this? We use, oops, I'm going a little crazy here. I guess it doesn't matter. All right. We need 5 minus 3. Oh, we will need the original equation. So let's put him in y2. Yes, we will. Okay, whoops. Pushing the wrong things. Okay, there we go. Let's turn him on, okay, in y2. And it'll be an orange color, okay? And there's kind of a reason why I wanted to do him second. You'll see in a minute, okay? We just need him for some values, these values to put in our numerator. All right, so we have 4x carried up to the 3 arrow over minus 2x, okay, and then plus 5. All right, let's graph. Yes, absolutely. Now, we need the table. The graph is great. It looks good. However, the table's where the values are. So second graph, see, that's where we get our table from. Now, we need to, and it is displaying, we need this, our interval values. We need the 3 and the 5. Let's look at the 5 first. So that gives us 495. 495 minus, what's that 3? 107. 107. Okay, what does that equal? Let's back out of this and let's go ahead and just pop that in the calculator, okay? Parentheses. Now, be wary of your order of operations here, okay? If you don't use the fractional setup, okay? I'm not using that. So 495 minus 107, close my parentheses, divide 5 minus 3. I got to use my parentheses. 5 minus the 3, close my parentheses, and there we go, 195. Okay. Now, let me show you what I'm talking about. Now, you may have watched other videos with me. You may have not. We need to say, to do this, what I want to put this setup in here. My rational, okay, my fraction setup. Okay, alpha and window, move over, arrow over to the left, 1, and highlighted 1 is what we need. Okay, now it's all set up and I can just enter them. Okay, 495 minus 107, arrow down, and 5 minus 3. Yes, we can just do 2. But I like to type in everything that I know it should be true. Okay, now let's push enter and we get the same value, 194. Now this is what I could write that a little clearer. What is this doing? The 194 is what we're measuring by. We're looking for this in our calculator, and that would be in our table of values that we have set up. That's what we're looking for. So let's go back to our table. Second graph. All right, now we have some values here that they're giving us. These are, let's read it again. For which value of C in the open interval, okay, can we get the 194? Okay, so this is what's really going on, guys. We've got our G prime, our C is here. Which value of C, which in our calculator would be where our X is, okay? See here? We need to find that value that will give us 194. Well, we can do that manually, or we can look over here in our calculator, okay? Well, we don't have decimals set up for our X, but we could do a little estimating. Before we put decimals in, look here. I am seeing 4 has 190 right here. Look. Okay. Now I'm looking at our pink because remember we put in our derivative first. Okay. Our derivative, our G prime X is the pink. So that's why I wanted the pink in, and it's convenient that it's a darker color. It's because that's what our eye goes to. So we know that this X has to be greater than the 4, but less than 5. So we've already eliminated option D. Okay. So, okay. And we could get this manually by doing this, by saying 12x squared minus 2 equals the 194. Okay. So then we have 12x squared equals, say, plus 2 on both sides. So that's 196. Divide both sides by 12, both sides by 12. This cancels to get the value of x. Okay, we need all of that under the square root, and that should work. Great, but let's do some estimating here. Good way to check it both ways, okay? All right, so let's go back to second window, and here is our setup. I want to look for, I'm going to say 4.04. Double check and see right there. Let's start with him because he's the lower value, okay? So I'm going to say I want to start my table at 4.04, and I want my table to be in increments of 0.01. And I like to push enter a lot of times before I go back. Now let's go look at our table. Second graph. Interesting. Look at what we get. And it lays things out for us. At the top of my table, I have 4.04, very convenient. And if you arrow over, that value rounds up. It is approximately 194. If I arrow up just a tad, I have to go back over, arrow down, arrow over. I arrow up to 4.03. It's way too small. So let me go back down. Okay, so looks like C is going to be the best option so far. But let's keep going in arrow to back down where we see the next option, B. Ooh, way too high. Well, if B is too high, A's value will be too large also. So the only even close estimate we have is this 4.04, which I'm sure was all estimated. Now, we have our option. Let's back out and double check the value that we actually have, okay? All right, so let's go second mode and put that in the calculator. Second, okay, we go second to x squared, which is our radical, and under the radical, we need, oh, let's put a fraction under the radical, okay? We don't have to, but let's just do it anyway. Okay, so alpha window, go over, arrow over to the left one. What we need is highlighted, so push enter, and there we go. 196, arrow down, and let's do 12, and let's enter. Okay, and it rounds very nicely, and obviously that option C is correct. Okay, this is the last question for this video. We have one more video left, one part for the Competency 10 quiz section, okay? All right, and thank you so much for watching and sharing and liking videos, as well as subscribing. The subscription numbers have gone up, and we greatly appreciate it. And once again, happy testing.